welcome to this video tutorial about pure data synchronization with other clients. My name is James Harkins. Today is going to be a little bit of a departure going into pure data. I've been using pure data in courses for about 3 years now, and recently came to my attention some ways of cooperating with other software, and so I thought I would collect some techniques to work with that into a video tutorial. So I'll begin with some introductory concepts, discuss the special requirements of external clock sources, and then we will look at two pieces of software, Ableton Link and PlugData. So, by way of introduction, something I've felt for a long time is that music software is much more fun when you're working with other people. Just a quick rundown of some techniques that are available. I think Maximus P has some of the best support for this, actually, because there is a global transport and you can change the clock source. So you change the clock source in one place and your whole patch will then work that way. Super Collider, if you are using Ableton Link, as we'll be discussing later, this is actually very easy because the link clock object is compatible with the normal tempo clock object. In Super Collider, I've had good results by sending MIDI clock out to other devices. MIDI clock in is it's a bit dicey, but it can sort of work. And for pure data, we will be talking about Ableton Link and PlugData. I do find in pure data, there are a lot of little problems that come up. So the main point of this video is actually to demonstrate some ways to handle these problems. I will also be demonstrating several of my own abstractions, which are available at this location on GitHub. Some of them I created just recently in order to handle some of these problems. So just makes the workflow simpler. As a demonstration, especially since we talk about sync, we want something with a pulse. So I prepared a bass line, a kick drum, and a hi-hat, which is right here. Let's make sure DSP is running. If you look in the lower left of the patch window, you'll see a mixing console. These are objects in my abstraction pack. I find them very helpful. So the sequencer in this example advances when it receives a bang. It will advance by 1/16th note. So we do need to initialize it, and we get event, bass note, okay. With these 16th note bangs, we can just automatically time them. So let's drop this, and now I'm going to say Metro 110. All right, so connect that to the players. And as Metro, of course, needs an on-off switch, so we'll create a toggle. I really like to reset on when you are starting. So we're going to take this, we're going to select. All right, so this is, why am I doing TFF up here is because we will need the on-off value to go in here separately. So we need these two branches to run independently. We get a bang out here, so we will reset. And this should be fine. So if we play this, okay, this is a very basic kind of timing model. If you've used Max or PD at any length, then you must have done something like this. So I would actually call this a prerequisite for the video. If you are not sure what the Metro and the toggle are doing, then you might have some problems with what comes later. So, go back and fill in some of those concepts. Now, we're going to build on this as we go. So next thing is Ableton Link and PlugData both express tempo as BPM. PureData supports tempo messages, at least some of the objects do. So you can write a tempo in terms of, say, 120 per minute. These seem to be kind of underused, not as well known as some other protocols in PD. Also be aware that a couple of objects related to timing don't actually understand them. So we will use per minute throughout these examples. One thing that is very important is that each object that needs to know the tempo has to receive the tempo message separately. This is something that while developing these examples, I forgot almost every time, and almost every time had to debug it. So I want to highlight that here. Okay, so we are moving in 16th notes. So we can actually write that just as a quarter of a beat. Okay, now let's make a tempo slider. We'll just pick a kind of metronome range here, tempo. Okay, and I want to clip that down to an integer. Now, to send this along, we need to format it as a message, and I'm going to use per minute, right, like that. So we'll take the number and stick it in here. This semicolon tempo is actually a send and receive type of thing. So I can receive tempo. This message comes out here, and we just plug it into the metronome, right? So, and actually there's one other thing. I would want to see actually what the tempo is. So I should put in okay, so let's go up to like 130, close to 130 or something. Now, when I run this, it's not going to work right away, but let's... It kind of almost worked. Okay. The one thing that was missing was the note slide. Make note does not understand about tempo. And I also didn't feed the tempo anywhere around there. So we need to take the note duration, how long it's sustaining, and convert that into milliseconds. There is some logic involved in that, so it's really helpful to use an abstraction for this. Let's look at this message format. We're taking two numbers, so we have a MIDI note number and a duration. Now, the duration here has been changed to beats. I did not change it here. So we were at 110 milliseconds per note, so that's going to be like a little bit less. But these have to be relative to 16th notes. So I think we want like that. This is slightly longer than a 16th note. This is about half of a 16th note. This is a little bit less than that. And a little bit less than that. And I think I got this one wrong too. Okay, so now we've converted these over. And once we do that, right, you see the bass is not doing very much because it's trying to treat these as milliseconds, and that's affecting the envelope. So because these are two-note lists, then we actually have to take them apart and do things. So I find it easier to create a thing. So in here we are getting a list of MIDI note duration. And we need to unpack this because on this side, we are going to take this duration as that. We're going to tempo to MS. This comes from my library. And then we are going to repack this and send this out. Come on. I actually like things to be fairly neat, if at all possible. Okay, and then this needs to happen before packing that into... Okay, let's use Magic Control K. Okay, and I am fussy about this. So now we should get... Why did it fail? Did I not just say this a little bit ago? I always forgot to send the tempo in. So we need to receive tempo over here. So I said it just a couple minutes ago, and then I did it again. Okay, we set the tempo. Okay, and now that's playing. So here is standard PD timing model with tempo control in BPM. Now, just a couple of notes about external clocks. The Metro that we used before, it just follows the sample clock from the audio driver, and it does not obey any other time source. We are receiving time information from an external source. So the timing object in Pure Data have to be passive. They have to wait until they get a signal to go on. Today, I'm going to recommend a clock multiplier approach. So we will have some control messages that are aligned with the beats and only with the beats. Then you can generate subdivisions based on any tempo and any metric division that you need. This is a matter of opinion. I really like to work this way. It is also possible to take a fast stream of time values and find the beat points or the subdivision points and then emit a bang at that time. So this is more like a clock divider in analog modular. Depends, you can try them both. I'm not going to develop this in this talk. I will use this approach throughout this talk, but just wanted to mention that it's available. It's a matter of opinion which one you prefer. So again, I'm going to mention gotchas, right? It's not that complicated, but it's complicated. So we need to be able to respond to the anchor points. This is a kind of trickier problem than it looks like. So right now, when I click this toggle to start, we just start immediately. We just declare this is the new downbeat. You can't do that when you're coordinating with other time sources, right? So then we have to be aware of where are we in the bar now, where's the next bar line, and how long to wait. And then the last thing is how to pick up tempo changes from outside. Related to this start and stop thing, rounding is very important. And especially when we want to know when is the next beat or bar, this is a round up operation. And the way we can do that in PD is add a value that is very close to 1, but not 1. Chop off, get down to an integer. We can also do some scaling to get a different division. So if we divide by 4, round to an integer, multiply by 4, then we're getting the next multiple of 4. Should be useful for a bar line, right? This is a bit of a heavy chain to create every time, so I put round and round up objects into my library. So I think with those concepts in mind, let's take a look at Ableton Link. What is Ableton Link? So this is a library created by Ableton for syncing over a local network. This library can be imported into any kind of music software. So Pure Data has the ABL Link external. Super Collider has a Link clock. One thing is that confuses people sometimes is you do not have to be running Ableton Live in order to use Link. Any Link compatible software will work. So credit to Ableton for disconnecting this library from their commercial ecosystem. You can use Ableton Link completely for free. Multiple computers or software on the same computer join the network. There is no leader or follower. They are all cooperatively working out this timeline. So they use messages over a local area network to keep adjusting to stay together. One way I say it is Metro is exactly consistent with itself, but in Ableton Link, all the players are a little bit inexact, but staying together. You lose sample accuracy, but you gain a kind of ensemble fun experience. An implementation detail is that you might need to use an offset parameter to get ABL Link to run slightly early, because the moment when the audio hits the speakers is a little bit after the time when it's computed. Configuring this gets kind of tricky, so ABL Link just this object kind of gives up and just lets you configure the offset. But it's just make sure not to forget about that. Now, the first question, we are getting some external data, so we need to be aware of like what are we actually getting. So let's go back to our patch. I don't want to overwrite my file, so I'm just gonna give it a dumb name. Let's add in path ABL Link. Not sure why DSP turned off right there. Okay, so we'll get ABL Link and go to the help patch, because this has a nice display of what it is. Okay, ABL Link needs DSP to be turned on. So if we look here where there's a step output, which is giving us beats, but only within the bar. Phase, which is giving fractional position within the bar, and that's updating very rapidly. There's an absolute beat number, the tempo, and this is playing thing, which is not connected at the moment. But that is, for example, if somebody presses play in a DAW, then this might sync up. This is what we get: beats, phase, beat position, tempo, and is playing, which I'm not going to worry about. So I recommended earlier using whole beats as a time trigger and using a clock multiplier. Now, right, there are a couple of things that we have to do. One is when you load the patch, you need to connect Ableton. Right, so, okay, so we're going to connect that. I had also mentioned an offset parameter, and I think the 0 to 127 should be fine for that. So we just need format with an offset and drop this in. Okay, now, so we are getting, we're getting beat numbers out here. To generate the subdivisions, I'm going to recommend another object from my library called Burst. This is inspired by a burst generator from Analog Modular. So we will take one beat and divide it into 1/4 units. Right, so if I do burst 1.25, let's put a bang underneath that. Now, if we connect this up, why is it not doing this? Again, tempo. Tempo is always the problem here, right? No, don't do that. Okay, so let's receive the tempo message. And, okay, if we slow it down, we see we are kind of getting... Next problem, how do you turn this on and off? This is always running. Answer is we need to block the messages when we're not playing. So we will need a spigot. And what opens and closes the spigot? See, we're not using Metro anymore. We do need to do, so we don't need that tempo. Let's shuffle over here. That's one other thing I need to put in here. So basically, we're going to take this. I'll use a send receive. So we have our on-off value, and we're going to receive the on-off value over here in the space. All right, so when we open this, then the beats should start going through. We have reset. The other thing I need to do is I need to convert these into a real bang, because we actually get numbers coming out of there. All right, let's run this. I think I got everything. Right, just for fun to kind of demonstrate that this is actually working. Let me get that. So this will be my live setup in Super Collider. We will use link clock as the timing source. And if I put this up here, you can see that the position within the bar is actually quite neatly synchronized, although, so the tempo got out of sync because I haven't hooked up the tempo yet. But yeah, let's play something on bar lines, just for fun. Okay. That's on the bar line. Now you can actually hear in here that Ableton is that PD is just a little bit late. Let's play with that offset. Okay, and so they are keeping time quite nicely. We will hook up the tempo in just a minute. One thing to keep in mind is Ableton Link tells you the tempo only when it starts. And when the tempo changes, if the tempo is not changing, then you might need to close and reopen the first time. Then the next time you open the patch, it should be fine. Okay, syncing to the bar line. Now, you noticed I had to count in order to get it onto the bar line. If we want it to start on the bar line automatically, then we need to grab one of these timing values, which tells us the exact amount of time, round it, subtract the current time, which will give us the amount of time to the next beat. Then, because we have to run a bit early, we have to subtract a little bit. And then this delay at that point will need that as well. So let's do, instead of S on off, we'll do PD next bar. Oh, I need inlets and outlets. So for the inlets, we're actually going to need two inlets. We're going to need on-off switch, and we're going to need another inlet. I'm not going to line these up for current time. Right. Now things get a little bit fun, and we really have to think about the data flow. So what we want to come out is the on-off value, but delayed. Right. So if you need to capture a value and then output it delayed, this is a really good use of a float box. So what we can do is we can save this value into the float box, and then we will trigger this other logic. So when we need to control the order, we need to use a trigger. So step 1, coming from the right, is we need to save the value over here, and then this will go to the outlet. Step 2 will be, coming out of here, is we need to freeze this time value. We need to get this time value and freeze it. Now, these time values are coming in fast, like, maybe 600, 700 per second. You don't want to run all of this logic here. So again, we use another float box to just instantaneously save this value. We don't do any of the work down here. And then when we need it, we just bang to get this out. Round up to the bar line, although we actually have to subtract from this. So that, again, is another trigger. I'm a big fan of triggers because they make your patches, it makes it very clear what your patch is doing. So we want the left-hand side of the minus should be round up. The right-hand side of the minus should be the original time value. Now we know which this is. And then, as noted in the slide, we need to subtract a little bit to make sure that we are head. And then this drives a delay. Now, what comes out of a delay is a bang. So we use that to fire off this, and then we're done. So let's see how that's going to work. Now, if I take this PD next bar, I plug into on off, and I think I can actually just use this one, plug that in there. Now, no matter what time I click this, it should go, except I'm going to catch myself because I had already said I need the tempo. So here is, as I said, it's a mistake that I made many times, and I'm continuing to make this mistake. Now, no matter when I click this, it should go to start making sound on beat 0. So, and it didn't work. Oh, it didn't work because I didn't reset the tempo. Okay, and there it is. So that works. Okay. Shall we continue? So with tempo changing, right? Tempo changes can come from anywhere. PD can change the tempo, and it should change everybody's tempo. Another peer can change the tempo, and Ableton PD should respond to that as well. So when you have bidirectional sync like this, there is a risk of message feedback. If I get a tempo change from outside, I treat it as a new tempo, I send it to everywhere. One of those places is Ableton Link. So the tempo goes back into Ableton Link. Ableton Link says, hey, the tempo changed. And then, you get a feedback loop. I did find this did not work very well. So to handle this, we need to tell the difference between two types of tempo change. Internal changes from PD itself just send the tempo along, and this needs to end up at ABL Link. A tempo change coming from Ableton Link needs to be sent to tempo, but it needs to be blocked from going back in. Another factor is I really don't want to have to make multiple, 2 different receive boxes for every place it needs a tempo. You see, already we've needed the tempo in about 4 different places, and it can only, as your patch gets bigger, this will only get more serious. So let's keep just one our tempo. Now, the way that I've done this is to use a spigot, kind of like a one-shot. It's a technique that I've used in other places. So you set the spigot's state, you try to push something through it, and then you either reopen it or reclose it. So we're going to do this. So we're going to get the tempo, and we're going to send the tempo here to Ableton. We're getting tempo messages from tempo. The format of the tempo receive is, as we've noted, tempo, so 1 per minute. We just need the number. So we can unpack, we can throw away the symbol, get the number. And then somewhere down here, we're going to have a spigot. We want to start with it open, so you don't know yet. This is ABL link tempo message. Format is just tempo. It assumes BPM always, so you don't need the other key. And then we will outlet this. Yeah. And then this will go up into the ABL link object. Now, how do we handle this spigot? Well, the way that I found that works pretty well is I will just create a flag for an internal tempo change. We'll pass this down here. And we need, again, here, this number needs to trigger 2 actions because we want to pass through and then reopen the spigot. So that, again, is a trigger. Now we pass this through. And then what do we do on this side? Well, we want to reopen. So we set a 1 status and we put in. So how does this work? So with this, we only send a message through here. Spigot is open, it goes through. If we get a tempo change out of here, then we'll get a tempo number from Ableton's tempo slider. And just in case, so we need to send 3 messages. I haven't created this one yet, but this is because we need to update the interface to show it. Then we will, at one time, we will close this flag. And then we will broadcast the tempo out to all of the other objects. Let's let that format. Okay, and it's very important for this one-shot spigot technique that the spigot message and the tempo message come immediately after each other. This way we'll guarantee that. So this will work. Last feature is we need to set these. Okay, let's do some testing. Right, I have a tempo slider here in Super Collider. And watch how that's linked up. So we can go slow, go fast. We can also go the other way. See how Super Collider is responding to this. Let's actually listen to that. Start real slow. Let's get our bar lines. Okay. Right. So this is actually what it takes to do Ableton Sync. I probably should build some more objects to kind of help with this. Again, to summarize the recommendations, I recommend to use the beat sync thing with a clock multiplier. I personally find it harder to sync beats if you're using a clock divider approach. And with the tempo, you have to do a little tap dancing to avoid message feedback, but it does eventually work. So that does it for Ableton. That's actually everything working for that. Let's turn then to PlugData. PlugData is pure data is wrapped in a VST. So this has some history to it. There's a developer named Pierre Guillot who created a library called Chamomile, which allows you to embed pure data into plugins. Then another developer, Timothy Schoen, wrapped this library inside a Juice interface and made a VST plugin out of it. So what we get from this is compatibility with DAWs. So if Max for Live works with Ableton, PlugData works with Ableton, it works with Cubase, it works with Logic, it works with Reaper. So it's kind of a nice thing. There are a few like little things that may be missing, but in general, as I've played with it, it's pretty good. So, for example, though, if you want to make an arpeggiator, and this is like first thing that I think of when I see this sort of plugin is how do we do sequencing? You need to be able to sync to the timeline. The way that Chamomile does this is there's a receive handle called playhead, which is shooting out, by my estimation, about 4,000 to 5,000 messages every second. With 44.1 kilohertz sample rate, you're getting about 689 control cycles every second. This receive handle is spitting out 6 or 7 messages for every time of that. So this is a lot of messages. And in fact, somebody there was an issue logged with PlugData, a bug report about like my patch is just too slow. It's because you really need to filter these before you do anything interesting. Second problem that I had found with this is that the data might not update for every one of these control cycles, so you get redundant data. We want to filter that out as well. And then also these messages are kind of interleaved by different symbolic keys. So if you want to filter out tempo changes, it's hard when the tempo is like every 6th message. So, I looked at this problem and made an abstraction to kind of clean up the data, make them a bit more user-friendly. And this abstraction gives you 3 outlets. One is ticks on the beat, consistent with what I said before. Second outlet gives you tempo messages, ready to use. And then the third gives you the other messages, which remove repeated values, and it also adds one message that will be quite useful. Unfortunately, the mixers are not compatible with PlugData at this time. So I'm going to speed ahead and modify the patch, and we'll come back when I'm done. So a quick little test of this. Okay, yeah, it still sounds kind of reasonable. So what else do we not need? Well, we're not using Ableton, so all of this stuff goes away. We also don't need the tempo stuff because the tempo is completely in control of the host. Pure Data shouldn't be controlling this at all. We will have to play around with this next bar thing a bit later, though. Okay. So we'll get the playhead tick object. One thing I note here is that playhead tick actually puts out a beat number and a duration of that time slice. This is meant for use with another object in my library, which I will not talk about today. Technically, we should unpack it. In practice, you can probably get away with it, though. So let's go ahead and strip off just that first one, and not to that inlet though. Okay, so we drive this. Tempo messages come out already formatted, and we already have lots of R's floating around for this. So all we have to do is that. All right. Let's get okay, PD sync. Now, that track, this is just created as a VST. It gives you an interface where we can, for example, go open patch. Should be okay. It's complaining a lot about some symbols, but actually it generally works. So what I'm going to do is I'm going to start the timeline rolling. Actually, let's go ahead and print these so you can see that. Because there's this MIDI item in here, so that's causing it to stop. Anyway, you can see that it is actually printing out the beats, and you didn't hear the bass line because this was not properly initialized. But we will take care of that next. Playhead tick gives you the beats. You use that with burst. Fine. Works fine. Obviously, we don't want to play in the project and then click a toggle in here, right? So actually this toggle needs to go away. I will do the editing in PD. You can do it in this editor, but I prefer to do it here. So to do that, I also found it helpful when I was working on this to know what time you play and start. You don't get that directly from Chamomile, but I added a message to my abstraction. I generate a message called root play at beat. So we take that from the outside. Root play at beat will give you a message in the format play at beat 1, and then some beat value for playing, or this might be a 0. So, and I've also found it most helpful to just pick up both of these. So we have a play state and a stop state. What do we want to do on the stop state? Well, we just want to send a 0 through to the spigot control, right? So when you stop, you get play at beat, you get a 0 here. We just close it and it stops playing. Now, what do we want to do on play? Well, let's for now just take a naive approach and just open the spigot. Okay, so let's say that. Don't say patch data. And I already forgot something. Okay. Right, we need to do a reset bang. Right, I'll just put that in there. I'll flip that over later. And we're starting right on the downbeat. So that much is fine. Now, here's where things get interesting. If you start playback in the middle of a beat, let's turn off snap. I will put myself like kind of somewhere in the middle of beat 2. Okay, so that failed, right? And this is where we get back to that question about how to delay the onset. And in this case, I think going to the bar line is not really useful. We can just go to the next beat. It's fine. So what do we get out of here? Here is where we get the time value. So I'm going to take this, change this to say PD next beat. We take the time value. This has to be rejiggered because we just get the time value. So we don't actually need the on-off. And We don't need that funny business because we just get this directly when we need it. This is not a stream of values, it's just a single value. So we take it, we will round it up to the next beat, subtract, and then we are just sending some messages from here. So actually the bang is fine. Right, so we will use this to bang this message box, reset, bang, on, off, 1. I think that will work. All right, close it, reopen it, and let's try it from this funny position. And there was a little problem that it's playing this fraction of a beat. Why was it playing this little fraction of a beat? Because actually I made a mistake all the way at the beginning. These values need to go through the spigot. They need to be under control of the spigot before they go to the burst. So now that will work. Right. Save it. Close it. And okay, and it's right on the beat, exactly where it should be. Now, having changed the playback logic, let's go back to the beginning of the timeline. Right, and this is a problem that I encountered while preparing all of this. Now that because we are delaying that on-off signal, it's not ready for this time value. So I had to do a really funny kind of workaround with this, where we subtract this in, then we want to check if it's smaller. If it's like really, really, really tiny, then we just do a bang directly out the outlet. And otherwise, we take the larger value and delay it. Is this crazy? This is a little bit crazy, but it's an example of the kinds of problems that you have when you are starting right on the beat. This needs to be immediate. When you're starting in the middle of the beat, it needs to be this way. Okay, so let's again save that and reload it. Again, you could do these edits in the VST window, but I just feel better about doing that. Okay, let's try it from the beginning. Please hope it works. Yeah, it's on. Okay, great. So, and just to kind of show that it really is synced, let's put the looping back on. I did add in a Vital soft synth, just a preset, but with a sequencer. Okay, and if we play them together, okay, and so that is just to kind of prove that the sync really is working. That is about it. Just a quick summary of main points for PlugData. Do not try to use the playhead messages directly. It's really, they're not useful. I put quite some work into this playhead tick object, so use it. Parsing out these play at beat messages is really important to start on time. Yeah, and that's really all of the content. So I'll just finish up by saying, timing is very easy until you have to play nice with someone else. There are a lot of pitfalls. You saw me even repeat some pitfalls during this lecture, but don't give up. It's as with anything in Pure Data, Max, Super Collider, any of these programming environments, the more you practice it, the more fluent you become at it, and then it becomes usable. So I hope that this presentation was useful. Thanks for watching. Okay, bye.